All right, everyone. How's everyone doing? Okay, this is our second Zoom online meeting. And in today's meeting, well, it's going to be a short one. It's a brief video. And it's just basically any last minute questions or any questions. How was that quiz everyone took? Was it a good quiz? Easy? Hard? No, man, bring it on. Yeah, I made sure to do a quiz so that I wouldn't understand who's in the class, who's not in the class, so then I can figure out what to do with my grade book, and I'm required to take attendance, but I was like, how do I do it when it's all online? So the quizzes are pretty nice, so just everyone, and I made them really simple, short and sweet, and I'm not really gonna grade hard on them. It's just basically, do you know how to use MATLAB? And if you know how to use MATLAB, or if you've done the first assignment, then you should be pretty okay. So, um, any questions that we have, or any last minute thoughts? This is open mic discussion night, so and BYOB, bring your own beverage, or Dr. Baker, Dr. Stuber likes to mention it. Bring your own beer. So, any good
I have a
questions?
question.
All right.
Uh, on number five, anything that's happening inside the brackets, is that just changing the index?
The index, yes. So basically, okay, I know what you're talking about. So I was talking to this about with one of the students. Like multiplying, like this one right here, you have 5b, right?
Yeah.
So okay then. Oh, oops, this is solutions. I'm just playing now. It's not solutions. It's something that accompanied the video for today. So, uh, admit all to the room. I don't like how Zoom makes me have to like individually click on people to come in. Um, But yes, let's do this. So it's gonna become EE360D. Um, Zoom call to. So, the assignments due Mondays, so that means this is pretty good to take some notes. So, the question's asking the exercise. It says generate the following signals for minus 25 to n to 25, and I asked to do hand calculations because well, I think I should have mentioned to do it right here because I was getting emails saying, how do we do them? And I'm like, to do the, I asked to do the hand calcs, estimated hand calcs. So, point is, do you know what it's gonna look like on a piece of paper? And if you do, then try to put it onto the computer. And if you know how to do that, then you can use your hand calcs and verify with both that you know how to put data into a computer. That's literally what I'm looking for number 4. However, let's try to generate a signal. So I'm going to call an n time from, let's do minus 5 to 5. Is that nice with you? And then let's do x. So x, I won't do the actual problem. Let's do something we can all see. So let's do x is going to equal um, n squared. And that should be a simple function. It's just a parabola, so it's just a function, but right now I'm just dealing with some arbitrary functions. So right now we're going to try and multiply by 2, but before we do that, let's do figure 1 stem n and x, just to make sure what it looks like. And then, where did it pop up? There it is. So that's a parabola. We all know that. So part D, no, so part B, D of n is asking for x of 2 of n. So on a piece of paper, maybe I should have made this one too. So x at 0, so if n 0, so 2 times 0 is going to be 0. So what's x at 0? So here's x at 0. I should have probably titled that. So let's do a title. Don't worry, we'll get to the fun part. Title x of n. Go. So this is x of n, so recall that. So remember that. And now we want to multiply this by 2. So at d of n is equal to 0, that means this is going to be 0. 2 times 0 is 0. That means we're looking at x of 0, so we're literally pulling this guy out. So we're pulling out this point. Now let's go to d of n is equal to 1. So now we're at n equals 1. So we have d of 1. Now we have 2 times 1. Oh, that's 2. So what's x at 2? So, we're here. So basically what's happening is we're skipping every second point going forward. And if you want to guess what's going to happen if we go backwards, that's what's going to happen. So the way I would probably approach this problem would be d is going to equal, and we're trying to double it, so that means here is going to be 4. I think it's multiplied by 2, so I think I would do this. I think 2 times n. Maybe that's going to work. Point is, this is going to be squeezed. So let's do that right now. I think this is what's going to do it. Stem. Oh my gosh, there's still people trying to get in. All right, there you go. Get them in. Figure 2. And if you've already watched my video, the latest one, let's use our new function that we've learned. Subplot. 1, 2, 1. And subplot 1, 2, 2. And let's copy this because I'm lazy. There we go. And let's look at D. Here's a problem. Actually, no, it's not going to be a problem. I think it should be fine. Oh, now I know what's going on. It's going to bark at us. You guys want to see it bark? Oh, never mind, it does it. Because this gets doubled. That goes there. X of 1. So that's 4. Yep, this is correct. Yeah, this is literally what I'm looking for right here. So the point that I'm looking for is, okay, oh, that's not X, that's D. So here I'm looking for, okay, at n equals 1, D of n is equal to 1. So here's 1. So here's D. We're looking at X of 2. So here's X of 2. So this point right here goes here. And now we're going to look at D of n equals 2, which is equal to X of 4. So here's 4, and that's going to be plotted right here. And then this pattern continues, and then you get the following graph. So with this, all you're doing is literally multiplying your original equation, which was this. Here's X. And then here is your new modified thing. So if you think about it, you can do the following. I don't think so you can do that. Because you can't put X in here because you can't multiply that by 2. But if you take the original equation, which is this, and then just put parentheses right there, that's how you do it. So that is a brief path into how to solve for number 2. So if you apply the same methodology, as long as your indexes are correct, then it should be fine, because D should be a length of 51 numbers. So 20 minus 25 to 25. So as long as that plot looks good. So the point is, it's going to look skinnier. And let's show you that. Because you can't see it here because it goes too high. Ugh, never mind. But that's the intuition for that problem. So did that answer questions, or did that make everyone more confused?
It's a little confusing because so we're not really manipulating X. We're just creating another function that's similar to X.
Yeah, that's how I would see it. But here's the problem with upsampling. So we're actually scaling this by a factor of 2. So we're increasing the frequency is what we call it. And that would call for this function would need to be bigger, and we can't have more than 51 samples. So for this one, I'm just looking for just copying and pasting that into there. There's nothing you can do with the original function other than if you wanted to apply some DSP tricks, it would be make the problem a little more challenging. But no, this is the bare minimum I'm looking for. So just yeah, you're gonna have to modify the original equation. So I think I should have reworded that one. That one's a bit tricky, especially this one. This one could also be a problem too. You have to also manipulate the equation, and that one should be bad. Not that bad. This one you'll have to manipulate it, and then this one's a nice easy one. So the ones that I won't grade too heavily on, or I actually won't grade too much at all. I just want to know if you can get the solution um, by trying your best. So this one and this one I won't go crazy on, so don't worry. But the one I'm looking at is for this one, because that one's an easy one. So make sure you know how to do this one. And yeah, all the simple ones, they'll be fine. But don't worry about this one. I've already had many questions about it, so it's a sampling problem. So um, you'll probably encounter that in 480 in the upper level division classes, where you actually have to create a function to allocate some more memory for your original x is what we're trying to do, because you don't have enough samples to create this. You would need double the samples. So don't worry too much about it. But are there any other questions, or did everyone get number 6 okay? Oh, there's a chat. Make sure it's recording. Yes, please record. Yes, we are recording. Thanks, chat. Oh yeah, I should probably. No, I'm not doing a face cam video, but if you wanted to see it, I'm okay. But yeah, this is all the people in our chat, and you can see them too. Any other confusions? Was the thing okay? Oh yeah, for the estimated hand calcs, you don't have to turn them in. This is for, well, when I say estimated, I say you can even draw this on a piece of paper. Like, so for example, if this was a parabola like x squared, and you know what that looks like, you can draw a picture like just like literally. Let's do an example. Like, okay, do x squared. Come on, where'd it go? Oh, there it is. If you can do this, like, oh, it's gonna look like this, and this point right here is gonna be 1, 1, 1, and then this one here is gonna be 2, and that one's gonna be 4. Then I'll know you know what to do. But if you know this, if you know that this is gonna look like this on a piece of paper, then try to make it look like that in MATLAB. And once you know how to do that, you'll be fine. This is all just generally if you know how to like manipulate data, input data, because in the second and following assignments, you're going to deal with crazy functions like cosines and sines, convolution, and transfer functions, and you probably won't know what those look like, and you'll probably be asking, oh, I don't know if it's going to look right. And yeah, you're right. It's going to get a little crazy, but don't worry. That's why this first assignment is going to be a nice like refresher and know what we're trying to generate. So yeah, so I wouldn't blame you for E and B. Don't worry too hard about it. Just make sure you know what it's gonna look like. You know it's gonna be doubled. This one's gonna double its index, and this one too. So don't worry too much on those. I am looking for this one. This one's a fun one. So, and then this one's a fun one too. You probably know what that looks like. Like if you can draw this, cough cough, you're fine. So I try to make sure everyone's trying to understand, like this one might be a little this one might be a little but that one you probably know. So anything else that was confusing or good or bad or actually where's my face cam? Howdy. So that's me. Anything else? We good? Or Or how about the exam? You guys ready for that exam? No. Well, the assignment's gonna be due Monday. Oh wait, there's comments. So nope. Nope, we're good. Or actually, here's the other question I can ask: are you guys okay with assignments being due before the exam, or do you guys want them due every week, or do you want them due sometime before the exam? Okay. Ask the answer for the exam before. All right, that's good. So would you want them every week, or would you want them just before the exams? Okay, I'll yeah, just do it before the exams because Dr. Stubert's telling me like, okay, David, you could decide if you want to make the class faster, simpler, or harder, or whatever. So he's giving me that freedom to make sure that you guys are successful. You love MATLAB. My semester of 360, our discussion professor kind of, well, he was cool, but he didn't really do anything other than just answer, give us answers, but we don't know what they are. But hopefully, I'll teach you all like what's going on. Like for example, with that problem, this one you require more samples. This one you'll require more points, but you have to create a new function. That's the sad thing about this part. But don't worry about that one. That's going to be a 480 problem unless you want to see that. Actually, have you all seen my new upload video? That video is discussing how to publish, how to do cool stuff in MATLAB, like make your stuff pretty. So actually, I will run that right now, and that actual video is right here. Boom. So I'll actually go over it. So for those who've assigned it, who already submitted the assignments, good job, and hopefully it looks good. I haven't looked at them yet. I'll be looking at them Tuesday morning, and hopefully getting them in sometime after that. But let's do this. So what I say is, okay, we have a title, and then I do this so that we can instantiate this as a title. Don't worry, it's for publishing options. Close all, clear variables, because suppose I do a different assignment. You guys want to see something cool? Okay, I'll show you guys some like crazy advanced stuff. So this is Dr. Shill's antenna MATLAB stuff. So we're doing some crazy plots. Close all. Forgot to put clear all. Should probably put clear. There, there. And then that shouldn't go here. I was like, okay, and this is a really good calculator. Make sure you do variables. Variables are your best friends because let's say you make a mistake down here, you got to change it right here. So it's all pretty simple. But crazy matrices and for loops. So you'll probably use your first for loop, and I think Dr. Stubert's already talked about it. So don't worry too much about it. Vectors. This right here is the arcsine function. You can all look at all this in Google. Scalars, and let's look at the output. Let's run that. Change folder, always change folder. Ignore that. And look at these plots. Pretty cool, right? And that's kind of what I do in the video. Not like this crazy advanced stuff, but really simple stuff. As in right here. So let's run this. Change folder. And this is probably a good example of what one of your plots could look like. All right, you probably did the assignment, so there you go. Ooh, look at that. Well, that's not the answer. I'm looking for the entire thing. This is E of n is equal to U of n minus 5. This is shifted. So I don't know if Dr. Stubert's talking about delays, but a delay is, well, a shift to the right. So suppose you had like you guys, those who were already at the beginning of my my engineering, sound engineering thing, you saw how the sine waves were moving from right to left into an input. That's exactly what this is. So all those signals are just going into some terminal. So this is basically being delayed. And if you don't believe me, I actually put another plot right here. So this signal is going to hit our sensor here. So here's like our sensor. And then these signals will just go, like, just travel to here. But this one gets delayed. So this is how you would like visualize a delay. So this one comes first, and then 1, 2, 3, 4, pause. 1, 2, 3, 4. So that's your delay. And yep, that's basically it. And for those who haven't really published it yet, the publishing function is a really simple function. Just watch the video. Oh, it's a joke. This is it right there. The publishing function is this tab, publish, but don't publish this. Go to edit. There's two ways of doing it, because by default it's HTML, and then a window pops up, and then here's your output, and then go to, you can either do doc or you can do PDF. If you do PDF, you can do that right here, and then it does crazy stuff in the background. Hold up, give me a moment. Can we publish on Octave similarly? I think you can. I think you'll have to look at how they publish it. I really don't know. But however, the equations like this, if you copy paste this into Octave, it will work. So as long as you can get the code to work, when in doubt, actually I'll do that example right now. You can do a doc, publish. Don't worry, I'll answer your Octave question right now. Okay, let it publish, let it publish. A window will pop up right here soon. Give me a moment. It should pop up. Let it move. These are two publishing options that you could use. You can either publish it as a doc, and this is what it will look like as a doc. So if you wanted to make any last minute edits, you can. And for my Octave friends who don't have access to MATLAB, what you can do is, let's go back to here. You can just copy and paste your code. And then for the figures, you can just snipping tool them into your thing. But as you can see, snipping tool takes a long time. You're probably going to be like, oh, snip. It's a lot of figures. It's a lot of figures. And that's why the publishing option is a really good thing. But I think Octave might have its own version, but that might be a last minute resort. But as long as I see the code and how you generated it and what you did, then it should be fine. So, okay, one thing I was seeing from a group chat, and it's an interesting thing, was, let's actually go back to here. This problem was this. No, that's okay. So here's our unit step function, but that's not colored in brightly. Let me highlight that more. That is figure 8. Don't worry, we'll probably hopefully be done by 6 o'clock. Figure 8. Let's make that bigger so everyone can see. Copy, paste. Yep, that's your favorite friend. Run section. So we have a unit step, and it starts right here at 0. To shift it, and I literally go over that answer. Oops, did I say that out loud? Just kidding. Here's our time. But where did I get this time? And that's the confusing part about trying to brute force stuff. And that's what the assignment tries to, like, maybe punish you if you try to do that. So the time I used was from -3 to 3. So my unit step goes from -3 to 3. So to delay it by 5, just add 5 here, and boom. That's where I got that number. However, what happens if you got the wrong time or the wrong thing, or you can't remember, and it gets annoying? There's a second way of doing it, and that's what I have this. So in the Dr. Stupid lecture at the top of the assignment, he tells you can call little numbers or call array boxes. So this right here calls the first point and the last point. These two will be your best friends also for any type of data analysis. So if you don't know what the first plot of your thing is, you don't know what the first point or the last point is, you just call it like this. And then I have a delay function, which is very useful. So like, oh, I was supposed to do a delay of 6. Easy, you can. And actually, I'll show you it right now. Watch. 6. So here's our unit. Here's our delayed unit step. And here's that. And just to make it fancy, let's do 6. And let's run that. As you can see, did it move? No, because this is a different NE2. There we go. And there you go, it shifted. If you want to see that in real time, I'll just simulate 10 delays. See, it shifts. And actually, let's go back to here. You want to see it shift in real time? Watch this. Combining stuff, run. Ooh, actually, that's not what it's supposed to look like. Let's run that again. There it is. See? The bigger your delay, the farther this goes away. So this is our input signal, and this is delayed. So pretty cool example to show you. Oh, how I did this? You can use create a figure. You can use the hold on function that holds on to all the data that comes after this function. So we're holding on to this. We're holding on to this. Hold off. If you don't do that, then bad stuff happens. And then I had a little legend. You can look up at the video that I posted today for more information on that. Creating titles, values, and boom. And you're probably looking at this like, oh, is that a MATLAB function? No, it's not a MATLAB function. That's a function we create in the video. This turns on a grid, which you can probably see there. Let's make the grid bigger. Let's make it 3. I'll show you right now. Close the window. Figure 9. There you go. Like that? Oh, that wasn't supposed to happen. There you go. So you can see that. So that's what this function does. So this just makes pretty graphs. So that's about all that I have to say in terms of publishing. And example 5, those 2 questions that were kind of in the blue. Yeah, someone was using circ shift. Don't use circ shift. You can, and they forced the number. I don't blame them. It's right. They're not wrong, but you could just move the time. All you had to do is just move the time. Just do this. That's all you had to do. You didn't have to modify it. Like E is equal to the unit step. Oh, you guys are engineers. You guys are the best. So don't worry. As whatever work rocks your boat, we tend not to modify the data. We don't want to modify. We don't even know what's in our data. Like we have a signal X and we want to keep X. We don't want to modify X, but we want to shift it. We want to modulate it. We don't want to modulate the actual amplitude unless we need to. So for those using circ shift, if you know what it's going on, but you're forcing values, you ruin the data. You distort the data. So it's right. However, let's say you have some crazy signal and then you use circ shift, and then you force the beginning to be something you want it to be, and you're like, but what happens if it changes? It changes over time, so do be wary about that. So try not to use circ shift, and that problem is this. So instead of using circ shift, you could have just done this. You could have done that. So, any other questions or comments or rants? Chat says we're good. Okay, looking good. Just gotta watch that video. Yeah, okay, for everyone, make sure you watch that video. It's about 40 minutes, and I try to make it as, comical and try to talk to you as best I can. Do recommend watching it if you've already halfway started it. It goes over through some stuff and even goes through this example that I've done and many more. So I really wish someone taught me how to plot actual graphs, like really nice graphs. My upper division professors were amazed that, like, wow, how'd you do this? It's just little, just researching stuff and looking up stuff. But I'm telling you this right now so that when you take your future classes, that you can really impress your professors and really impress your friends and use MATLAB as a calculator. So with that, I would like to say thank you all for coming to our little live discussion, and I'll be ending the chat right now. All right. Take care, everyone. Cancel this. Share and then call.